Hello everyone, my name is Sławek Kapuński. I work for Red Hat, and today, together with Miguel, we want to show you what is new in Queens and what is in Neutron Quality of Service and what we introduced in last cycle. So, at the beginning, agenda of today's talk. First, I will do some short introduction to what quality of service in Neutron is. In overall, I will show you what are existing features related to QoS, how it's implemented on backends, and then we will talk about new features added in Queen's cycle, and Miguel will talk a bit more about what we plan to achieve in Rocky and beyond. So, basic concept of quality of service in Neutron is quite simple. We have policy, QoS policy, which contains rules, or rule or more rules. And this policy is attached to network or to port directly. If policy is attached to network, it will be applied to all ports connected to this network, unless port has own policy attached to it, then it overrides this network policy. Data model looks like on this picture, so those black lines are not very visible here, but QoS policy, one QoS policy can be attached to one or more ports or networks. Port can have only one policy attached to it at once, and policy can contain rules. These rules, there is some basic abstract rule type in Neutron, and real rules are extending this basic rule type. There are some limitations how many rules can be attached to policy. For example, you can't attach two different DSCP marking rules to one policy because it wouldn't work at all. So you can have at most one DSCP marking rule attached to one policy, but of course you can have DSCP marking rule and bandwidth limit and minimum bandwidth rule in one policy if you need. So now, how to use this quality of service in Neutron? First, from user perspective, what needs to be done is to create policy. As on this, like on this slide, it's some policy without any rules. It can be, of course, attached like that to port, but it will have any effect yet. So, second thing is to create some rules in this policy. Rule is created directly in policy. It's every rule must be inside some policy. Like on this example, it's the bandwidth limit rule with some limit values. This rule is in this policy called summit policy, as it's shown here on slide. And now this policy can be, of course, attached to port, which is done by simply by calling port update. For example, with OpenStack CLI client, like here, policy ID is then listed in port attributes, and that means that this policy is attached to port, and rules from this policy are applied by a backend driver to it. So, for example, like here we have bandwidth limit rule inside policy, so this limit will be applied for traffic going out from this port on the backend. Speaking about backends and rule types, different backends supports different rule types. Here's the matrix of what is current state in Neutron. So as you can see, bandwidth limit is supported for Egress and Ingress traffic by OpenV switch, Linux bridge, L2 agents, and also by layer 3 agent. for floating IPs. SRIOV supports only egress traffic limiting. Minimum bandwidth is, for now, supported only by egress traffic, for egress traffic by SRIOV agent, and DSCP marking is, of course, for egress traffic supported by OpenVSwitch and Linux Bridge. Little bit about each of those rule types, how to create them, what are parameters, and how it's implemented by different backends. First, bandwidth limit rule. To create such rule, you need to give max bandwidth value, which is this parameter max kbps. You can also specify burst value. If you will not specify, it will be automatically calculated by backend. It's quite important to set this value properly, because if you set it as too low according to bandwidth limit which you want to achieve, then you will always have your bandwidth limit will be lower than you wanted to set to have. If this burst will be too high, then your real speed will be higher than expected. And third parameter is direction for rule. Here it's Ingress. It can be also Egress. Egress is default value, so it don't need to be specified if you want to limit traffic outgoing from port. How layer 2 drivers, agent drivers are implementing it. OpenVSwitch agent for Ingress traffic bandwidth limit will create some QoS and Q records in OVSDB, and then apply this QoS to port, to tap port on host. This QoS has max rate set with value exactly what was specified in Neutron API, and as we always have only one queue in this QoS, all this bandwidth max rate is consumed by this queue in our case. For egress traffic, we are using Ingress polysync on interface available for Ingress polysync for traffic on OpenVSwitch interface. Why it's Ingress traffic? Because we want to limit traffic which is going out from instance. And speaking about QoS on host inside the bridge, it's traffic. We need to look for this traffic from bridge perspective. So traffic which is outgoing from interface is incoming to bridge. That's why we need to, for egress traffic rule, we need to do polysync on Ingress QDisk. Underneath, OpenVSwitch will use TC, traffic control from Linux kernel to apply this to interface. In case of Linux Bridge agent, we are using TC directly. For Ingress traffic, we are using token bucket filter, which is simple classless QDisk and works very fine with limiting whole bandwidth for whole traffic outgoing from interface. For egress traffic, we are also, Linux Bridge agent is also using TC directly. In fact, it's setting Ingress polysync on Ingress QDisk for a tab device on host, and it's exactly the same thing which is done by OpenVSwitch if you will set Ingress polysync like was shown a few slides ago. SRIOV agent is setting bandwidth limit directly on VF as a VF attribute. there is no burst value supported in this case. So it's if you have rule with some burst value and apply it to QoS to SRIOV port, then it will be just ignored, this setting. Next rule type is DSCP marking rule, which can be used to mark some packets going out from your instance, from port. Only attribute which is necessary for this rule is DSCP mark with some value. There are some specific values available. Not any integer can be set, but there is some list of values in documentation. And this is supported by both Linux Bridge and Open vSwitch agents. For Open vSwitch, it's set like using OpenFlow rule in integration bridge. This rule is sets TOS type of service field in IP header with specific value. And for Linux Bridge, we are using IP tables, and we have some specific QoS rated chain in Mangle table in post-routing chain. Now, minimum bandwidth as a third of rule types which we have. It can accept parameters like minimum value of the bandwidth required and direction. For now, it's only Egress is only supported direction. There is no possibility to set Ingress. Any backend supports Ingress minimum bandwidth for now. So now, that was the. Let's say now talk about new features which we introduced recently, and first of such features is rule types validation. Because at the beginning, when we introduced QoS in Neutron, there was no any validation. As you can see, you could see on the previous slides, some rules can be applied and are supported by some drivers. Different are not supported. Some backends not support some rules. So there was nothing what could prevent, for example, to set not supported rule types to port. And so only thing which was at the beginning available in Neutron, there was API call to to list supported rule types, and it then returned only rule types supported by each of loaded mechanism drivers. So, for example, if you have deployment with Open vSwitch and SRIOV mechanism drivers, you will get only bandwidth limit rule as available. Because DSCP marking rule is, for example, supported by OVS, but not SRIOV, so it won't be on this list. That makes some problems and troubles for users. For example, first of all, from user perspective, there was no real validation, and even if there was only bandwidth limit rule reported by this list call, API call, nothing prevents you to create DSCP marking rule, for example, and attach it to SRIOV port. Then it would be it was applied, and user could think that everything works fine, but in fact, any packets wasn't marked with DSCP. Second thing, of course, we could simply forbid to create, for example, DSCP marking rules in a cloud where only bandwidth limit was available, but that could make problems with deployments where, for example, you have some hosts with Open vSwitch and some hosts with SRIOV, because then you couldn't use DSCP mark on any host, and in fact, it could be possible and should be possible for OVS hosts. And third thing was that when we start working on Ingress bandwidth limiting, we realized that some of attributes, for the same rule type, there are attributes which can completely change character of this rule and how it's handled by backends, like direction, for example. So we need also some kind of validation to check if this rule type with specific attributes is supported by driver or not. So we create new validation way and new API calls. First of all, we changed the rule type list call to support, to return rule types which are supported by any of loaded driver, not by all of drivers. And second thing is that we added new API call to get details about rule type. This API call is admin only, to not expose infra details to the user. And you can check and get from API informations about, for example, the DSCP marking rule type is supported by OpenVSwitch driver in this deployment, and it can accept such parameters and such values for this parameter. Together with that, we did this validation. So now every create or update rule call to API or create update port or update network when you want to attach QoS policy to this network will be validated. And if you want to attach policy with rules which are not supported by port, by driver which bound port, then you will have HTTP conflict error response, and you will see from API that you cannot use this policy, QoS policy, and rules with specific ports. Like, for example, I created two policies, one with DSCP marking rule only, and second with minimum bandwidth rule only. And I had port which was bound with OVS driver. So when I wanted to attach this minimum bandwidth policy to this port, I got a conflict exception because minimum bandwidth is not supported by OVS backend driver, QoS driver, and when I want to attach this DSCP mark policy, then it's attached to port, and backend driver can apply it for this port. And now about bandwidth limits for floating IPs, we'll talk Miguel.
So my name is Miguel Lavalle, and I work for Huawei. I'm the Neutron PTL, and we are going to talk about first what we incorporated during the Queen cycle, as far as floating IPs, and then we are working on new exciting. We're going to talk about new exciting features that we are working right now to incorporate in quality of service. Let's see if I know how to operate this thing. Now I know. Okay. So in the case of floating IPs, we only implemented bandwidth limit rules. We support both Ingress so we support essentially both directions. And as you might remember, in the case of floating IPs, it depends. A floating IP can reside in a network node. In the case of legacy routers, or it can reside in the compute nodes in the case of DVR. So one of the key challenges when we were implementing this functionality was to decide where the bandwidth rules needed to reside. So essentially, the rules we came up with 3 rules which are pretty simple. In the case of legacy routers and high availability routers, the TC filters are applied, the policy is applied in the QG device. And the QG device, if you remember in a Neutron router, you have a QG device which connects to the outside, and then you have the QR devices which connect to the inside. So essentially, we are connecting that to the QG device. In the case of DVR, distributed floating IPs, distributed routers. We have another namespace, which is the we have a namespace in each one of the compute nodes, and in that case, we are applying the policy to the RFP device. And in the case of we have what we call a DVR edge routers, which are these are DVR routers where the floating IP is not bound to a port, and that's again we centralize that, and as a consequence, the policies applied to the QG device in the SNAT namespace in the centralized compute network node. And finally, it's important to mention that the filters are applied when the floating IP is associated to a port. So following Slawek's example of the summit policy, in this case, I'm assigning a bandwidth limit egress rule to that summit policy. And likewise, I'm assigning an ingress rule to that same policy. And then I go create my floating IP. And essentially what I do in this case is, in my floating IP creation, I specify the name of the policy or the UUID of the policy, and that policy is applied to the floating IP. The floating IP, the policy can be applied during floating IP creation, or it can be applied, or you can update your floating IP with a QoS policy to it. We create an instance. I didn't include the instance creation in the slides, so we create an instance and we associate that floating IP I just created to one of the VM ports, and now we can see in the system that we have applied the policy. We have two queuing disciplines in that namespace, and in this case, this is a legacy system. This is a legacy router, so you can see that we apply that to a QG device in the router namespace, and you can see the filters that were applied to for the egress rule. And also you can see oops. Okay, no, wait. You can see what we applied to for the Ingress rule. So this functionality was delivered in Queens. We continue working on it in Rocky a little bit. We've been scrubbing and cleaning it, and we're adding a Tempest test to the Neutron Tempest plugin. So please take a look and let us know what you think about it in your deployments. So now we come to the big feature that we are working on during the Rocky cycle, and that's a strict minimum bandwidth support. What do we mean by strict minimum bandwidth support? Well, Slawek talked about minimum bandwidth rules in our QoS policies. What those minimum bandwidth rules do is to enforce a minimum is to guarantee a minimum bandwidth to that port at the data plane level in the compute host. But nothing prevents today NOVA to schedule a number of instances on that compute host in such a way that the NIC, the device where we apply those minimum bandwidth rules is oversubscribed, because NOVA and the NOVA scheduler doesn't have any concept of those commitments that we are making with a minimum bandwidth rule. So what we mean by a strict minimum bandwidth support is that now we are working on making sure that we create that minimum bandwidth rule, and at the same time we let NOVA and we let the scheduler know that we made that commitment, and that as a complete system, we need to honor those commitments to the users. That's what we mean by the strict minimum bandwidth support. For the time being, we are working within Egress minimum bandwidth rules in SRIOB, and we have plans to add other backends as time passes. For the time being, we are going to release this feature during Rocky as an experimental feature, and we are really looking into getting feedback from the community on how useful this is. So as I said, we need to cooperate. We need Neutron and Nova talking to each other to make sure that this actually happens. Limitations of this first experimental release: the port. The big limitation that we are going to have in this cycle is that the port where you apply the minimum bandwidth rule has to be pre-created by the user, and then you take that port and give it to Nova during the instance in the instance creation command, instead of specifying a network. And the reason for that is that today the way Nova works is that if Nova were to create the port, that port would be created by code running in the compute node. In other words, by code, that code runs after the scheduling decision has been made. So we need to be able to make a decision as to where we are going to schedule that instance, and we need to make that decision based on the minimum bandwidth commitment that we made. So that's why, for the time being, we are to use this feature, we need you to create a port, associate the QoS policy, and then provide that port to Nova during the instance creation. There's been a blueprint in Nova for a couple of cycles already, where they are going to be moving the creation of the network resources for the instance to the conductor. And by moving that to the conductor, what's going to happen is that the port creation and the port binding is going to happen before the scheduling decision is made. And then we are going to be able to create these kind of things with you specifying just the network and having Nova create the port for you. So to be able to do this, we need 4 components. We need four steps for this to happen. First of all, we need Neutron to communicate to Nova the bandwidth resources that we have in the different compute nodes. Nova needs to, when Nova schedules the instance, it needs to know, okay, this is the inventory of bandwidth that we have in each one of the compute nodes, and therefore, since this this instance has a port with this minimum bandwidth requirement, it's going to be able to make the decision on what compute host to schedule the instance. So, of course, the user needs to set a Neutron bandwidth requirements in his or her port, and Neutron needs to communicate to Nova the minimum bandwidth requirement for that port. And finally, when Nova makes the scheduling decision, Nova needs to communicate to Nova the selected host and the backend selected based on the bandwidth requirements. So let's go step by step. What we are going to be doing is we are going to be talking to the placement service. Placement, for those of you who might not be familiar, placement is a service associated to Nova where you can specify resources available in the different compute hosts. So essentially, the basic abstraction in the placement API is what they call a resource provider. And a resource provider is a source of some resource. In this case, we are talking about bandwidth, right? So we are going to create resource providers through placement, specifying the different bandwidth inventories that we have across the compute hosts. So associated with a resource provider, you have inventories, which are consumable resources. In this case, we are talking about bandwidth. And on the other hand, you can associate trades to those resource providers. And trades are non-consumable qualities of the resources. And in this case, we are going to see exactly how we are using trades to implement this functionality. So what we're going to have is that for each compute host, we are going to create a number of resource providers. First of all, when placement starts, and when Nova starts, a compute resource provider is created for that compute host. That happens whether we are cooperating with Neutron or not. Placement always does that. And the reason placement does that is that that's the root of the tree where you can add more resources associated to that, more resource providers associated to that compute host. In our case, what we are going to do is we're going to create for each agent in that compute host, for each backend running in that compute host, we're going to create a resource provider. That's going to be the second level. So as you can see in this case, in this example, we have, in this compute host, we have two backends activated. We have two agents. We have OVS and we have SRIOV. And then associated with each one of those backends, you will have physical NICs, physical interfaces. So we are going to associate with each one of those backends the NICs that each one of those backends is managing for the user. And underneath those, each one of those resource providers is where we are going to add the bandwidth inventory. We have, as you can see, you have an Ingress inventory, an Egress inventory in each one of those leaves in the tree. And what the scheduler, the Nova scheduler, is going to do is it's going to say, okay, I'm receiving a request to create an instance, and that instance has a port that needs this minimum requirement. The scheduler is going to ask to placement, give me a host, give me candidates where I can fulfill this minimum requirement. And additionally to it, you can see that with each one of these resource providers, we are associating two traits. The first trait is the physical network associated to the corresponding NIC, and also the VNIC type that physical VNIC can support. And the reason we do that is that as we are going to see, the way we communicate from Neutron, the bandwidth requirement to Nova requires that placement has that information. So each agent is going to provide its bandwidth inventory through the placement API to Nova, and we are using a two-steps process here. Each agent, using its configuration, is going to, using the RPC channel, where it's going to provide the inventory of VNICs, inventory of bandwidth, and the associated traits to the Neutron server. And that's going to be done through the agent heartbeat. Today, every agent in the reference implementation of Neutron sends a heartbeat periodically. And within that heartbeat, there's a configurations field that is going to include the bridge interface mappings. Today already includes that, but we are adding the resource provider inventories and the resource provider traits. And then what the Neutron server is going to do with that is that using the placement service REST API is going to populate the trees in the placement service. So we create a minimum. We create a policy, a rule with a minimum bandwidth requirement, and we associate that policy to a port. So that's going to be the 2 steps that the user needs to take, and the user then provides that port to the Nova boot command, and Nova is going to take that port UUID, and as part of the steps of creating the networking resources for the instance, Nova does a get port. That happens today. That has happened forever, and in that get port, we are going to add a new attribute to the port. So what we are trying to avoid here is having Nova to talk to the make another REST API call to Nova to get the QoS policies. So we are piggybacking on the existing calls that Nova does anyway to Neutron, and we are adding a new resource, which is a resource request that is going to include, in a summarized way, the minimum requirements for that port. In this case, 1,000 kilobits per second. And we are also sending the physical nets where that port's network has access to, can be deployed on, and the VNIC types that are supported by that backend. So with that information, the Nova scheduler is going to say, placement, give me a set of candidate hosts that can allow me to fulfill these bandwidth requirements. And when the Nova finally makes its placement decision, it's going to communicate back to Neutron the decision it made. It's going to communicate the host where that port has to be bound, and it's going to communicate the UUID of the resource provider that was selected to support that bandwidth support. This is a network. This is a port update call that Nova sends to Neutron. This call already happens, anyways. It's when Nova asks Neutron to bind the port in the specific host where that Nova has been scheduled. The only thing that we are adding here is that in the binding profile, we are adding a new key, which is the allocation that is going to contain the UUID of the resource provider selected during the scheduling process. And that's it. Questions? By the way, the specs for this functionality, there's one spec on the Nova side, there's one spec on the Neutron side. Both the specs are approved. They were approved over the past 2 or 3 weeks. So we are full steam ahead working on the implementation of this during Rocky.
You said the QoS show required admin privileges to run that command?
Yes, this QoS rule type show command. It's hard-coded that it's only for admin. Yeah.
Yeah. Why is
because this command shows you what backend drivers you have loaded in your cloud, and that's something what we discussed and decided that shouldn't be exposed to the cloud user because it's some information about infrastructure, in fact, and that's why.
Okay.
Sorry?
No. As long as the policy is shared, when the admin creates the policy and that policy was created shared, yeah, you don't need any special privileges. Yeah. So we are at time. It's 12:30. Thank you for coming. If you have any questions, please talk to us, hunt us down in the hallways, and we'll be happy to answer your questions. Thank you so much for coming.
Thank you.